So today we're going to take a look at multiplying polynomials that are bigger than binomials. We'll start with a trinomial times a binomial. I'm on page 31 of the Power Law, Powers and Exponents booklet, and I'm doing even ones because the odd ones are assigned for you. Remember that you can multiply two numbers in any order. I think of this as, because they're in brackets, two numbers. So I'm going to actually rewrite it so that the smaller, the binomial, is first. And then I'm going to just take it logically. It's 2x times this entire bracket. And then it's plus 3 times this entire bracket. So now I just have to make sure I multiply properly and then collect like terms. So 2x times x squared is 2x cubed. 2x times 4x is 8x squared. 2x times 7 is 14. Then over on the next bracket, it's 3x squared. Oh, sorry, thank you, 14x. And then back over here, I had 3x squared, that part I did right, plus 12x plus 21. Then I collect my like terms. I only have one x cubed term, so that doesn't collect with anybody, but I have two different x squared terms. They add up to make 11x squared. I have a couple x terms. They add up to make 26x. And the 21, the constant, doesn't have anything to combine with. So that's it. That's my answer. I'll give my class a second to catch up to my writing. All right, next example. Number 4 on the same page. This one involves a negative. And I'm actually going to do this one a little different. Just like when you're multiplying numbers, you can do them in columns. I'm actually going to multiply this together in columns. At the end of the day, I don't really care which way you do this, so long as you do them right. Now, when you're multiplying numbers in columns, you line them up according to place value. In this case, I'm going to line them up according to the fact that they're like terms. So I'm going to start with my 5 times negative 3, which is negative 15. Then I'm going to go 5 times negative 3x, which is negative 15x. Then I'm going to go 5 times 3x squared, which is 15x squared. Then I'm going to start multiplying with my other term, but I'm going to start in the x place. So negative 2x times negative 3 would be positive 6x. See how I'm lining that up? Just like normally you'd leave a 0 there in that spot. Then it would be negative 2x times negative 3x, which is, again, positive 6, but this time it's x squared. And then I have negative 2x times 3x squared, which is negative 6x cubed. Now I just collect my like terms by adding them up in columns. Negative 15. Negative 15 plus 6 would be negative 9x. 15 plus 6 is 21x squareds. And negative 6x cubed. This is a positive, so a plus goes here. Yeah, the question I had was, so you just multiply everything as if they were numbers? And the answer is, yeah, think about it. If I had, say, 421 times 21, notice I would just take the ones place and times my ones, tens, and hundreds. But then on my next pass through with the number that is in the tens place, I leave the ones place blank and go 2 times 1 is 2, 2 times 2 is 4, and 2 times 4 is 8, and then I start adding up. That's exactly the way I approached it here. I think of my constant as its own place value, so it starts here. But then when I start my next round of multiplying with my x place, I don't put anything here because that's not going to be a constant. It's going to line up with its like term, the x's. So let's do one more like that, just to make sure we got it. In fact, let's make sure we do it with a bigger one. Here's a trinomial times a trinomial. So we're going to do this in columns. Now, just like I would with normal multiplying, again, I realize that it doesn't matter what order I do it in. So I'll put the one that's easier to multiply with on the bottom, just like I would if I was doing this with numbers. The one with the smaller terms, I think, is the one that's easier. And this actually kind of will move a little bit to the left. So I think I'll just move that over a bit. And OK, so I'm doing this as a multiply. So negative 3 times negative 5 is positive 15. Negative 3 times 6y is negative 18y. Negative 3 times 2y squared is negative 6y squared. Leave a blank because there's no more constants. Negative 4y times negative 5 is plus 20y. Negative 4 times positive 6 is negative 24y squared. And negative 4y times 2y squared is negative 8y cubed. Leave a space here because there is no y term for the last set. And now it's y squared times negative 5 is negative 5y squared. Y squared times 6y is positive 6y cubed. And y squared times 2y squared is 2y to the power of 4. Collecting like terms. Don't have to worry about carries in these either. 15 is just 15. Negative 18 plus 20 is plus 2, plus 2y. Negative 6 minus 24 more is negative 30. Minus 5 is negative 35y squared. Negative 8 plus 6 is negative 2y cubed. And 2y to the 4 has nothing to combine with. And there you have it. Okay, one more example. Let's take a look at what happens when you actually times 3 binomials together. Again, order doesn't matter, so I'll just multiply those two together first. So that's going to be my foiling, so that's going to be x times x. First times first is x squared. Outside times outside is minus 6x. Inside times inside is minus 5x. And last times last is plus 30. And all of that is still being multiplied by x plus 3. So those two are like terms. So before I do any more multiplying, I'll simplify that. And now I'm at the point where I can choose to do it the first way or the second way. Whichever one you like better. I'll go back to the first way since you've seen me do two column ones in a row. I'll think of this as x times the bracket. Oops. And then plus 3 times the entire bracket. So put all that together and I get x cubed minus 11x squared plus 30x plus 3x squared minus 33x plus 90. Now last step is collecting like terms. The x cubed has nothing to combine with. Negative 11 plus 3 is negative 8x squareds. 30x's minus 33x's is minus 3x's. And the plus 90 is a constant with nothing to combine with. And there you go. That's about as tough as anything I'd be asking you. If you can do these examples here and the ones on the same pages on the odds columns, you'll be plenty ready for the next test.
Wait, where did you get that x?
Where did I get what x? Where did I get this x from? I multiplied this by the entire bracket and then this by the entire bracket. The question was, where did I get this little x from? Any other questions? All right. Good luck on the homework.